Today we're going to be learning about patterns that have a constant ratio. First, let's really talk about what we mean by a constant ratio. When a pattern has a constant ratio, it means that each term in the sequence is multiplied or divided by the same number to get the next term. So if we look at an example over here, we've got a pattern that goes 1, 2, 4, 8. If you go from the 1 to the 2, and you try and find a constant difference, like we learned about patterns with constant differences, you'll see that from 1 to 2, it increases by 1, but then from 2 to 4, it increases by 2, and from 4 to 8, it increases by 4. So that's not a constant difference. So now we look for a constant ratio. So what we're going to do is we're going to see what do we multiply or divide by to get to the next term. So if I take 1 and I multiply by 2, then I will get 2. And if I take 2 and I multiply by 2, I will also get the next term, which is 4. If I take 4 and I multiply by 2, I will get the next term, which is 8. So in this example over here, we've got what we call a constant ratio of 2. Okay. Now, sometimes the constant ratio can be negative. If you've got a pattern where the numbers or the terms alternate between positive and negative, it means that you've got a constant ratio which is negative. Okay, so let's have a look at an example like that quickly. So over here, I've got my pattern 2, -6, 18, -54. Now, as soon as you see a pattern where it's alternating between positive and negative, it's going positive, negative like that, then that's a hint to you that this is going to be a pattern with a constant ratio. Okay, so in this example over here, if I want to work out what my ratio is, I'm going to see what must I multiply 2 by to get -6. I need to multiply 2 by -3 to get -6. So over here, I multiply by -3. Now, if I multiply the second term by -3, I will get the third term, which is 18, positive 18. Remember, when you multiply by a negative, it's going to change sign. That's why it's alternating between positive and negative. So when I multiply a positive by the -3, I get a negative. But then when I multiply the negative by -3, I get a positive again. Okay, so then I'm going to take my positive 18 and multiply that by -3, and I get -54. So in this example over here, we have a constant ratio of -3. Now, sometimes, like I said in the beginning, a constant ratio isn't only when you're multiplying by something, it can also be when you're dividing by something, which, remember, multiplication and division are related to each other. So if you've got a pattern where you've got a constant ratio where each term is being divided by something to get the next term, then you can work out what the ratio is by tipping and timesing. Because remember, when you divide by something, if you tip and times, you can change that into multiplication by flipping over whatever is after the divide sign. So over here, in this example, we've got the pattern 9, 3, 1, 1/3. So in this case, I am dividing from 9 to 3. I'm dividing by 3 to get from 9 to 3. Then if I divide by 3 again, I will get the 1. And if I divide by 3 again, I will get 1/3. So in this case over here, it's a constant division that's happening. Okay, so now to work out what our constant ratio is going to be, we take the division, which is dividing by 3, and we tip and times, and that will give us multiplication, where we're multiplying by 1/3 and multiplying by 1/3 and multiplying by 1/3. So dividing by 3 is the same as multiplying by 1/3. So it is still a constant ratio. Even though it looks like we're dividing, it is actually still multiplication. It's just multiplying by a fraction. Okay, and so that means that we have a constant ratio of 1/3. So the ratio is whatever you are multiplying by. It's not what you're dividing by, it is whatever you are multiplying by. Okay, so now let's have a look at an example. In this example, you've been given the pattern -3, -6, -12, -24. We need to look at this pattern and answer some questions about it. Okay, so the first question is we need to write down the next 3 terms. Okay, so let's have a look and see what is happening as we go through this pattern. To get from -3 to -6, I could subtract 3. But then if I subtract 3 again, I'm not going to get -12. So I don't have a constant difference here. So let's look and see what else it could be. Another way of getting from -3 to -6 is by multiplying by 2. So if I multiply -3 by 2, I will get -6. If I multiply -6 by 2, I will get -12. And if I multiply -12 by 2, I will get -24. So in this example over here, we've got a constant ratio where every time we go from one term to the next, we are multiplying by 2. So if we do the same thing to the -24 and we multiply by 2, we're going to end up with -48. And then if we multiply that by 2, we'll get -96. And if we multiply that by 2, we'll get -192. So our next 3 terms are negative 48, negative 96, and negative 192. Okay, for the next question, we need to describe the pattern in words. So when we describe this pattern in words, what we need to do is explain how we get from one term to the next. So the way that we get from one term to the next in the pattern is we multiply by 2. So the first thing we're going to say is that we're going to multiply by 2. So each term is multiplied by 2 to get the next term. Then we also need to say where we are starting from in the pattern. We are starting from negative 3, because if we don't say that, there are an infinite number of different patterns we could have where we are multiplying by 2 from one term to the next. So we need to also give that information about where we are starting from in this pattern. So when you're describing a pattern that has a constant ratio, you need to say how you are getting from one term to the next. What are you doing? You're multiplying or you're dividing by a certain amount. And then you also need to say where you're starting from. Okay. Now for question C, we need to find the nth term. That is the rule for this pattern. So let's have a look at how we would find the rule for this pattern. So the first thing we need to do when we're trying to find the rule for a pattern that has a constant ratio is we need to identify what that constant ratio is. Now we did already discuss this. We said that this is multiplying by 2. We are multiplying by 2 from one term to the next throughout this whole pattern. Okay, so my constant ratio is that I'm multiplying by 2. Now let's have a look at what is actually happening when we are going from one term to the next, starting with the negative 3. So my first term is negative 3. Okay, then the next term I could have written as negative 3 multiplied by 2. The next term I could have written as negative 3 multiplied by 2, and then multiplied by 2 again, because that's what I did to get from there to there. I multiplied by 2, and then to get to the negative 12, I multiplied by 2 again. And then my last term that I have over here, I took the negative 3, and I multiplied by 2 to get negative 6, and I multiplied by 2 to get negative 12, and I multiplied by 2 a third time to get negative 24. Okay, so over here, that is actually just writing each of the terms out kind of as products of their prime factors. Now this can also be written as negative 3, and then negative 3 times 2, and then negative 3 times 2. 2 times 2 is 2 squared, so that's times 2 squared. And then here, negative 3 times 2 to the power of 3. Okay, now I want you to have a look at this quickly over here. See what's happening to the exponents for the 2. So over here, you can't see it, but remember, when you can't see an exponent, it is a 1. Okay, so over here, my exponent is 1. Over here, my exponent is 2. And over here, my exponent is 3. So my exponent is increasing from one term to the next. Okay, so I've got negative 3 times 2. The base is staying the same because that is what my constant ratio is. Every time I'm multiplying by that same amount. So the base is whatever that constant ratio is going to be. So I'm multiplying by 2. So it's going to be another 2 that I'm multiplying by. So it's going to add to my power of 2 over here by adding to the exponent. Now over here, this is the only one that doesn't have a 2 to the power of anything. But remember, I could actually write this as negative 3 times 2 to the power of, now remember, if you've got something to the power of 0, it is the same as 1. So over here, I could write this as negative 3 times 2 to the power of 0. So what I've actually got going on here is I've got 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. And every time it's being multiplied by whatever my first term was. So this is how we're going to get our rule. Our rule is Tn is equal to, we're starting with whatever the first term was, which is negative 3. And we're multiplying that by whatever the constant difference is, which in this case is 2. And then the exponent. Now look over here. This term is term number 1. So n is 1. This term is term number 2. This is term number 3. And this is term number 4. So here n is 1, n is 2, n is 3, and n is 4. Now look at what our exponents are. So our exponent over here is 0, our exponent is 1, our exponent is 2, and our exponent is 3. For each term, the exponent is 1 less than the term number, which is our n value. So what I can do over here is I can say that my exponent is going to be whatever n is. So if over here n is 4, my exponent is going to be whatever n is, it's 4 minus 1. It's 1 less than whatever the term number is. So it's negative 3, my starting number, multiplied by the constant ratio to the power of n minus 1, which is my term number. So it's 1 less than my term number is my exponent. Okay, so that's going to be our rule for this particular pattern. So over here, my rule is going to be Tn equals -3 times 2 to the power of n minus 1. Okay, so now we're going to use that to help us with the next question, where we have to work out what the 12th term is in the pattern. Okay, so now I'm going to use that rule and replace the n with 12, because in the 12th term, n is 12. Okay, so I'm going to be working out what T12 is, and to do that, I replace the n with 12. So now I've got -3 multiplied by 2 to the power of 12 minus 1. Now we have to work out what this 12 minus 1 is, and that gives me 2 to the power of 11. So the 12th term is -3 times 2 to the power of 11. Now this, you're not going to be expected to work this out yourself. So you can use your calculator, type in -3 times 2 to the power of 11, and that will give you -6,144. Okay, so that's how you would do a question like that. Right, so now I'm going to give you a few that you're going to do for yourself. The first one that you're going to do, you've got the pattern 3, 9, 27, and 81. So you're going to go through the same basic steps, the same kinds of questions that we had in the last one. First thing you're going to do is find the next 3 terms. Then you're going to describe the pattern in words. Then you're going to find the rule for the pattern. And finally, you're going to determine what the 9th term in this pattern is. Okay, so I'm going to give you 2 minutes for this question. Okay, so let's go through that and see what you should have got. Okay, so first of all, I'm starting with my pattern over here, 3, 9, 27, 81. So you can see straight away when you look at it that it's not going up by a constant amount. It doesn't have a constant difference. So let's look for a constant ratio. So you should have seen that to go from 3 to 9, you have to multiply by 3. And then from 9 to 27, you can also multiply by 3. And from 27 to 81, you can also multiply by 3. Okay, so over here, I've got a constant ratio of 3. So let's have a look at what our next 3 terms are going to be for question A. So for the next term, I'm going to take the 81 and I'm going to do the exact same thing again. I'm going to multiply that by 3. So I have 81 times 3, and that gives me 243. So my next term is 243. Then I'm going to multiply that by 3, and that gives me 729. And then I'm going to multiply by 3 again, and that gives me 2,187. Okay, so that's what your next 3 terms should be for question A. Then question B, you had to describe the pattern in words. So now when we're describing this pattern in words, like I said, we're going to talk about how we get from one term to the next term. What do we do to one term to get to the next term? So each term is multiplied by 3 to get the next term. Okay, so that's the first part of our description, is how are we getting from one term to the next term. But we also have to say where it's starting. Otherwise, this could be anything. It could be 1, 3, 9, 27 if we were starting at 1. Or it could be 10, 30, 90, 270 if we were starting at 10. So you have to say where you're starting to actually make it specific to this particular pattern. So starting from 3. Okay, so that's what your description should have looked like. That you need to say that you're multiplying by 3 from one term to the next, and that you're starting at 3. Okay, then question C, you had to find the rule for this pattern. Okay, so our rule is Tn is equal to, now remember for the rule, you're going to say what you're starting with, which is 3, and multiply that by the ratio, which is 3, to the power of n minus 1. Now this particular pattern could also actually have been written slightly differently if you wanted. You could have written it as Tn equals 3 to the power of n, because the 3 and the 3 are the same base. So if you use the laws of exponents and you multiply them together, you will end up with 1 plus n minus 1, the 1 and the minus 1 cancel, giving you just n. Or you could also look at it as your pattern is 3, 9, 27, 81. 3 is 3 to the power of 1. 9 is 3 to the power of 2. 27 is 3 to the power of 3. So each time the exponent is the same as your term number. So over here, this is another way of writing this particular pattern's rule. This isn't always possible. It's only possible because the first term was the same as the common ratio or the constant ratio. Okay, so that's what our rule looks like. Then for question D, we are going to take the rule and we're going to use it to help us to work out what the 9th term in this pattern is. So I've got T9 is equal to 3 times 3 to the power of 9 minus 1. That's the same as 3 times 3 to the power of 8. Okay, so I'm going to use my calculator to work that out. So I've got 3 times 3 to the power of 8, and that gives me 19,683. If you had your rule written like this, it would look like that over here. T9 equals 3 to the power of 9. And that is going to give you the same thing as what we had over here. So 3 to the power of 9, 3 to the power of 9 is also 19,683. Okay, but like I said, writing it this way is only an option when the first term in your pattern is the same as the constant ratio. Okay, right, now we're going to go on to the next example. So in question 2, you've got the pattern 5, 50, 500, 5,000. And this one, again, you need to find the first 3 terms, you need to describe it in words, you need to find the rule, and then you need to find the 10th term in this pattern. So I'm going to give you 2 minutes for this one as well. Okay, so let's go through that question and see what you should have got. Okay, so first of all, we're starting with our pattern, 5, 50, 500, 5,000. The first question, once again, is to find out what the next three terms are, to write down the next three terms. Okay, so to work out what the next three terms are, I need to see what is happening in my pattern. So to go from 5 to 50, we are multiplying by 10. Then we're multiplying by 10 again to get from 50 to 500. Then we're multiplying by 10 again from 500 to 5,000. So our constant ratio here is 10, and we're multiplying by 10 every single time. So the next three terms are meant to do the same thing. I'm going to take the 5,000 and multiply by 10. That's going to give me 50,000. Then I'm going to multiply by 10 again, and that gives me 500,000. And then I multiply by 10 again, that gives me 5 million. So that's what you should have got for your next three terms, 50,000, 500,000, and then 5 million. Right, then question B, we have to describe the pattern in words. So once again, we're going to start off by saying, what are we doing to get from one term to the next? We need to multiply, in this case, by 10. So each term is multiplied by 10, which is our constant ratio, to get the next term, okay? But that's not enough. I also need to say where the pattern is starting. So starting from 5, which is our first term over there. Okay, so that's what you should have had for your description. Then question C, we had to find what the rule is for this pattern. So the rule for this pattern is Tn equals, and then we have to go and work the rule out by taking the constant difference and the starting number. So I start off with a 5, that's my first term, and I'm multiplying that then by 10 over and over and over again. So it's 5 times 10 to the power of n minus 1. Okay, so Tn is 5 times 10 to the power of n minus 1. So that's what you should have had for your rule. And then question D, determine the 10th term in the pattern. So the 10th term is where n is 10. So now I've got T10 equals 5 times 10 to the power of 10 minus 1. That is 5 times 10 to the power of 9, which you can use the calculator for if you want to, but you shouldn't even need to, because you should know that this is 5 and then 9 zeros. That's actually basically the same as when we were working with scientific notation over there. Okay, right, so that was question 2. Now question 3. In this question, you've got the pattern 5, negative 10, 20, negative 40. You need to find what the next three terms are. You need to describe it in words, find the rule, and then you need to determine what the 11th term in this pattern is. Let's give you 2 minutes for this one as well. Okay, so let's go through that question and see what you should have got. Okay, so first of all, I've got my pattern over here. Now remember I told you, as soon as you see a pattern where the terms are alternating between positive and negative, so over here we've got positive, then negative, then positive, then negative. That means that your constant ratio is going to be a negative number. So over here, I need to multiply 5 by negative 2. So I'm multiplying that by a negative. Then I need to multiply negative 10 by negative 2 as well. So I've times negative 2. Then I multiply this by negative 2 as well, so times negative 2. So every time from one term to the next, I'm multiplying by negative 2. And that's why it's changing sign all the time, because every time you multiply by a negative, you're going to change sign. Okay, so now we're going to go and find what our next three terms are. So for question A, if I take the negative 40 and I multiply that by the constant ratio, which is negative 2, I'm going to get positive 80. Then if I multiply that by negative 2, I will get negative 160. And then we just multiply that by negative 2, and that gives me positive 320. So your next three terms should have been 80, negative 160, and positive 320. Then question B, we have to describe it in words. Okay, so in this pattern, our constant ratio is negative 2. So what we're doing is we're taking each term, we're multiplying it by negative 2 to get the next term. So each term is multiplied by negative 2 to get the next term. Okay, and then we also have to say where the pattern is starting, and it's starting at 5. Okay, so that's what your description should look like. Next, we have to go and find the rule for this pattern. So the rule is going to be working with our first term and our constant ratio. So for question C, we have Tn is equal to, and then our starting point or our starting number is 5, multiplied by the constant ratio, which is negative 2, to the power of n minus 1. But now I have a problem, because if I just write it like that, then this is not negative 2 to the power of n minus 1. It's just negative, and then 2 to the power of n minus 1. I have to put the negative 2 in brackets, because that whole thing must be to the power of n minus 1, because I'm multiplying by negative 2 every time. I'm not just multiplying by 2 every time, I'm multiplying by negative 2 every time. That is the reason that it's alternating sign like this. If I don't put the negative 2 in brackets, it's not going to alternate sign. It's going to be negative all the time. Okay, so you need to be careful about that. That when you've got a negative ratio, it needs to go in brackets. Okay, so question D, we now need to go and work out what the 11th term in the pattern is. So T11 is equal to 5 times, in brackets, negative 2 to the power of 11 minus 1. That is the same as 5 times negative 2 to the power of 10. So now we go and work that out. So I've got 5 times negative 2 to the power of, now you see on my calculator, it automatically puts that in brackets when I put in negative 2. I don't know if you can see that. Okay, so it automatically puts it in brackets. If yours doesn't, you need to make sure that you put it in brackets. Okay, so it's the power of 10. And that gives us 5,120. So that's what you should have got for the 11th term for that pattern. Okay, right, now let's go on to the last one for today. So question 4, you've been given the pattern 160, 80, 40, 20. You need to work out what the next three terms are, describe it in words, find the rule, and this time you're going to find the 9th term for this pattern. Okay, so I'm going to give you 2 minutes for this one as well. Okay, so let's go through that and see what you should have got. So over here I've got my pattern 160, 80, 40, 20. Now in this one we are dividing from 160 to 80, we're dividing by 2. From 80 to 40 we're also dividing by 2. From 40 to 20 we're also dividing by 2. Okay, but now remember we said that our constant ratio isn't what you're dividing by. We have to turn this into multiplication. So when we divide by 2, it's the same as multiplying by a half. So this is the same as times a half. So that is what I'm going to be using for my constant ratio is a half. Okay, so over here, my next 3 terms, so I'm starting with 20 over there to get my next term. I'm going to be dividing that by 2 again, so that's going to be 10. Then I'm going to divide that by 2 again, and that gives me 5. Then divide that by 2 again, and that gives me 5 over 2. Or you could write it as 10, 5, and 2.5 if you want to. Okay, so you can write it as a common fraction, or you can write it as a decimal fraction. You can also write this as 2.5 if you want to as well. Okay, so long as you have that value, whatever way you write it is fine. Okay, then question B, we have to describe what this pattern is in words. Okay, so when we're describing this in words, now in this case, you can say multiplying by a half, but you can also say dividing by 2. So I'm going to say each term is divided by 2 to get the next term. Okay, now just like I had to do when I'm doing multiplication, I have to then say where I'm starting. So from 160, or starting from 160. Okay, so my first term is 160. So that's what you should have for your description. You could also have said that it's being multiplied by a half if you want to. Okay, then question C, we have to find what the rule is. So this is where we have to use the half. So our rule, Tn, is equal to, our first term is 160, and that is being multiplied over and over and over by a half. Okay, so it's multiplied by a half to the power of n minus 1. Okay, so that's what your rule should have looked like. And then question D, we have to work out what the 9th term in this pattern is. So T9 is equal to 160 multiplied by a half. Please also note over here, I'm putting the half in brackets, just like I did with the negative ratio. When you have a fraction, you also need to put it in brackets. Otherwise, the exponent actually only applies to the numerator if you don't put it in brackets. Okay, so I have to put it in brackets. So to the power of, in this case, it's 9 minus 1. So that is the same as 160 times a half to the power of 8. And now we can go and work that out. Okay, so 160 times, I'm going to put in a half as 0.5 because it's easier to type, to the power of 8. And that gives me 0.625. So that's one way of writing it. You could also write it as 5 over 8 as well if you want to. So either way is fine. Okay, and that's what you should have got for that question. And that is how we work with patterns that have a constant ratio. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.